Welcome to PreMath. In this video, we have got this green shaded rectangle along with this yellow shaded circle with the center O, and their only point of contact is D, put together as you can see in this given diagram, such that this chord CD is 16 units and this diagonal AD is 9 units. And bear in mind that all these points A, D and C are collinear. And furthermore, these points B, O and C are collinear as well. And now our task is to calculate the area of this yellow shaded circle. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started, and here's our very first step. Let's make an observation. We can see this point B is the point of tangency. So therefore this AB is going to be the tangent and this line is going to be the secant line. So therefore we are going to go over the basic concepts, and let's recall the tangent secant theorem. As you can see in this given diagram, and here we can see this is our tangent line and this is our secant line. Then according to this tangent secant theorem, we can write this one as PA square. We are talking about this segment PA whole square, and that is going to be equal to the segment PB times the whole segment PC. As you can see over here on the right hand side, we got PB times PC segment. And now we are going to apply this tangent secant theorem on our given problem. So therefore we can write this tangent AB whole square equals to this segment AD. I can write down this segment AD times this whole segment AC. Let me write down times AC. And now we can see our this AD diagonal is 9. So I'm going to replace 9 over here. And likewise, this whole segment AC is going to be 9 plus 16 is going to give us 25 units. So I'm going to replace this AC by 25 over here. So therefore I can write AB whole square equals to 9 times 25. In other words, AB square equals to 225. And now I'm going to undo this square by taking a square root on both sides. So therefore we can see that our this AB length turns out to be positive 15 units. So thus our this segment AB turns out to be 15 units. And here's our next step. We are going to connect these points B, the center O, and this point C. As stated before, these points are collinear, as you can see in this next step. And indeed, all these points lie on the very same line as well. And now let's recall the circle theorem. According to this theorem, the angle between the radius and the tangent line will always be 90 degrees. So no wonder this angle has got to be 90 degrees, since this is our tangent line and this is our radius. And now let's make an observation. We can see that this BC is the diameter of this yellow circle. I'm going to label this OB as the radius lowercase r, and likewise this OC is going to be radius lowercase r as well. So therefore this whole diameter BC is going to be 2 times the lowercase r. And now let's focus on this right triangle ABC. We know its side length AB is 15 and this side length BC is 2 times lowercase r, and its hypotenuse AC is going to be sum of these two individual lengths, 9 plus 16, that is going to give us 25 units. And now we are going to apply the Pythagorean theorem on this triangle to calculate the value of this radius r. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our two legs are 15 and 2 times r, and our hypotenuse is 25. So let's go ahead and fill in the blanks in this Pythagorean formula. So 2 times r whole square plus 15 square is going to be equal to 25 whole square. Let's simplify. That is going to give us 4r square plus 225 equal to 625 on the right hand side. And now we are going to subtract 225 from both sides, and here we can see they cancel each other out. So we got 4r square equals to 400. Now we are going to divide both sides by 4, and here we can see our r square value turns out to be equal to 100. And now I'm going to undo this square by taking square root on both sides. So therefore we can see that our radius lowercase r turns out to be 10 units. So thus the radius of this yellow circle turns out to be 10 units. And here's our final step. Now we are going to calculate the area of this yellow shaded circle. And now let's recall the area of a circle formula. Area equals to pi r square, where this lowercase r is the radius. So therefore our this yellow circle area is going to be equal to, we are going to write down pi times our radius r is 10. So I'm going to write down 10 whole square. And now we can see 10 square is 100. So therefore this yellow circle area turns out to be 100 times pi square units. And furthermore, in terms of decimals, this yellow circle area is going to be approximately equal to 314.16 square units as well. So thus, after all the calculations and manipulations, the area of this yellow circle turns out to be 100 times pi square units, and that is going to be approximately equal to 314.16 square units as well. So therefore the area of this yellow circle turns out to be 100 times pi square units, and that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.